Good morning. Welcome to today's lesson on section 8.6. Section 8.6 is about solving rational equations. It will be the last section we'll cover in chapter 8 because we do have a test this coming week during block number 2, which will be Wednesday for E period and Thursday for periods B, F, and G. Sorry, no worksheet, didn't have time, but this will be a pretty short video because I am running pretty tight on time here since I got to head out of town. But let's start with example number 1. Let's say you had the following: 3 over x plus 1 equals 9 over 4x plus 5. So this is called a rational equation because we have two rational expressions on each side. So in this case, what I'll do is I'll just cross multiply. You can cross multiply if there is exactly one rational expression on each side. And I'll talk about why that works that way a little later. But we can cross multiply if there's exactly one rational expression on each side. So if I do that right now, I have 3 times 4x plus 5 equals 9 times x plus 1. Very simple. Distribute. Move things around. And you get x equals -2. Now you do have to check for extraneous solutions. But really what you're looking for, make sure denominator is never 0 in the original equation. So if I go back, if I plug -2 into here, that's cool. Plug -2 in there, that's cool. So -2 is our final answer. And by the way, the instructions were to solve, not simplify or do anything else. And this was example 1 on page 589. So let's try another one now. Let's step up our game here. Number 2. We're going to solve the following equation: 5 over x plus 7 over 4 equals -9 over x. And this is example 3 on page 590. Now in this case, we can't cross multiply as a first step. That's because I have two fractions on the left side. And really when you think when you're cross multiplying, really what you're doing is you're multiplying everything by the LCD. Notice how the LCD for up above, number 1, was x plus 1 times 4x plus 5. So it's like I multiplied both fractions by the LCD, because if I multiply this, let me change colors here for a little contrast. If I multiply this by x plus 1 and 4x plus 5, I multiply this by x plus 1 and 4x plus 5. Notice how those crossed off and those crossed off, which got us down here. So that's what cross multiplying really is. It's multiplying everything by the least common denominator for all fractions involved. So that's what I'm going to do over here as well. It's kind of a ubiquitous way of solving these. Kind of a fancy word to use there for ubiquitous if you are studying SAT vocab. So LCD for everything. Not for one side, but for both sides. I want to emphasize that. For both sides. simply going to be 4x. So now what you want to do is multiply each fraction by the LCD. And here's how you do it. It's going to be 5 over x plus 7 over 4 equals negative 9 over x. Now, I'm not trying to add or subtract these fractions. I'm actually simply just going to do this. 4x times this, 4x times this, and 4x times this. What some students do is they figure, oh, well, let me do this. They'll multiply by 4 and 4. They'll multiply by x and x. And then multiply by 4 and 4 here. That could work, but you're asking for trouble because it's a lot more work, and you're likely to make a careless mistake. So don't combine fractions. Instead, it's kind of a fun name, but I call it bust the fractions. So you want to break these fractions. We don't want fractions anymore. So I'm going to bust them. I'm not going to combine them, because that's just crazy. Why would you want to combine them when you can just bust them? Hopefully you guys find that kind of funny. But anyway, 4x, 4x, 4x. So notice how these x's go away. So you have 20. And so it's almost like I'm just multiplying to the numerator, but then canceling out at the same time. 4 goes away, so I have 7x. X goes away, I get negative 36. Look how nice that is. That is a super nice equation to solve. If you try to combine the fractions and then do all this crazy stuff, you're asking for trouble. This is my way, and you should do it this way. You get negative 8. Done. And just check to make sure none of the denominators are 0, so it's all good. Alright, let's try another one where we can bust the fractions. Number 3, which is the following. Okay, so the LCD for everything, because that's what I said, find the LCD for everything, is actually just going to be this. That's why we did this work on Friday of adding, subtracting fractions. Because if you think about it, x squared minus 9 is really just that. So what's the next thing? Bust it. That's the next thing I'm going to do. Got this giant grin on my face because I think it's just funny. So you want to bust the fractions. So here's what I'm going to do. Let me rewrite the problem, but we need a little more space here. Use red to show what I'm doing. Gone, 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 gone. So what we have now. 6x plus 18 equals 8x squared. And I'm going to be a little bit careful here. Notice how I already distributed the 6x plus 3 on the left side. But let's be careful on the right side with the negative 4x and x minus 3. Because you got a negative and a lot of stuff going on there. That'll be negative 4x squared plus 12x. And again, 6x plus 18. So this is like a quadratic equation, which we've done before. So you kind of see how everything builds upon itself. You have 8x squared. Jeez, hold on. Okay, I don't know why I typed in the... Okay, let's try this again. You have 4x squared. You have 0 on this side. Plus 6x. minus 18. You can factor out a 2. 2x squared plus 3x minus 9. You can factor it. That'd be a negative 6 and 6 and negative 3. So we got 2x squared plus 6x minus 3x minus 9. Makes it plus negative. Factored by grouping. 0 equals 2. Factor out of x, 2x actually, x plus 3, plus negative 3, x plus 3. Then you can pull out the x plus 3. You have 2x minus 3. Don't worry about the 2 because it's a constant. There's no x there. So the only x values that we can get out are these, negative 3 or 3 halves. But here's the problem. Negative 3 makes that 0. So that's not going to work. That's extraneous. So the answer is just 3 halves. So that's what you got to look out for extraneous solutions. If you were to graph actually the left side of the original equation, the right side of the original equation, and try to find points of intersection, you would only find one point of intersection, and that would be at x equals 3 halves. Okay, last one. Number 4. Then I have to get going so I can start enjoying my weekend. Let's say we have the following. 1 minus 8 over x minus 5 equals 3 over x. By the way, number 3 here was example 5 on page 591. So this one here is example 4 on page 590. So LCD for everything is going to be this, because you have x minus 5 of x, and 1 is just 1 over 1. Now bust it. Here's what we're going to do. I'm going to multiply this by x and x minus 5, multiply this by x and x minus 5, multiply this by x and x minus 5. Gone, 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 gone. Let's take a look at it. You have x minus 5 minus 8x equals 3x minus 15. X squared minus 5x minus 8x equals 3x minus 15. Clean it up. And that should be pretty easy to factor. I think I get a, let me think here. Oh, negative 16. Oops. Oh, wow. Sorry about that. It's negative 16x. Okay, let's try again. 15, negative 16, negative 1, negative 15. X minus 1, x minus 15. So you get two answers, 1 or 15. And both will work, because we won't make any of the denominators 0. Okay, so hopefully this made sense. And hopefully on Monday, when you have your sub, you'll be able to do the problems for section 8.6 in class. And then I'll see you guys on Tuesday, or if you're GP, I'll see you on Wednesday. And enjoy this weekend. Super Bowl will be a tough one to predict. I think it'll be New England 27-24, but anything could happen. So enjoy the game, and I'll see you guys later this coming week. Goodbye.